Conduction of electrical impulse in the axon. The myelinated nerve fiber in the central nervous system is designed in such a way that the action potential traveling through is faster and quicker. So what is the resting membrane potential? Resting neuron maintains an ionic gradient across the plasma membrane, creating an electrical potential between the neurons as well as the surrounding environment. When the appropriate stimulus reaches the neuron, it excites the nerve cell, causing the electrical potential gradient to be reversed, and the plasma membrane of the neuron is said to be depolarized. So this potential with which the plasma membrane excites is called as action potential. So the potential developed in the neuron can be traveled in either direction, and the repolarization of the plasma membrane caused by the ionic exchange restores the resting membrane potential. So if you talk about the speed as well as velocity of the nerve, the velocity of the conduction of the nerve mainly depends upon the myelination of the axons. Myelinated nerve fibers carry impulses at a faster rate compared to that of non-myelinated nerve fibers. So in myelinated nerve fiber, the myelin sheath around the nerve fiber acts as an insulating material, keeping the transmission of the current fast, mainly in order to have a minimal energy loss in this myelin sheath, which is regularly interrupted along the length of axon by nodes of Ranvier. So this arrangement greatly increases the rate of conduction of the impulse, as the axon here is naked and the ions can freely pass through the plasma membrane from the extracellular fluid. So the action potential jumps from one node to the other and sets depolarization, which get transported from one node to the other like a grasshopper jumping. So this type of leaping of action potential from one node to the other, occurring mainly in myelinated nerve fiber, is called as the saltatory conduction. And the impulse reaching the cell body stimulates axon hillock area, which is said to be the neck of the axon, and it passes passively through the myelinated area of the axon, and after reaching the nodes of Ranvier, the signals get amplified by triggering the voltage gated channels and is passed on to the next node, which further amplifies the impulse and carries forward the impulse. So because of this arrangement, the conduction of the nerve impulse is approximately at a rate of 80 meters per second. And in case of non-myelinated nerve fiber, the action potential passes continuously along the axon lemma because of there is no presence of nodes of Ranvier in an uninterrupted fashion, thereby decreasing the rate of conduction dramatically and rapidly, that is approximately up to 4 meters per second. And the conduction of the nerve impulse along an axon also depends upon the diameter of the axon. The larger diameter axons conduct the impulses at a faster rate compared to that of the smaller diameter axons. That's the reason group A fibers, which have larger diameter, can conduct impulses at a faster rate when compared to that of the group C fibers with smaller diameter. So the transportation of the substances within an axon is in both directions of the axoplasm, and if the transport is away from the cell body, it is anterograde transport or flow, and if it is towards the cell body, it is called as retrograde transport or called as retrograde flow. This is what you need to know about the axonal excitation.